Hello and welcome to SudoKanard. We are here to solve this arrow Sudoku by Christoph Seeliger for the qualifying round of the German Sudoku Championship. So this was the second highest pointer in the set, and I kind of dreaded the puzzle when I tackled it quite near to the end. It's the last puzzle that I solved during the 2 hours, and fortunately, I pretty soon found the break-in because I had already seen such a setup in another puzzle. So the special rule of arrow Sudoku is that whenever you have a circle followed by an arrow, the digit in the circle is the sum of the digits on the arrow. So that's it. And in some cases, you could have repeating digits along an arrow, but this is not the case in this very puzzle because it would just break the rules of Sudoku. So what can you see? Well, you can see that in the center, almost all digits are on an arrow. And there is a digit that can never lie on such an arrow, and it is digit 9. Because we have two digits, and 9 plus something is bigger than the digit that you will put in here. So in the central box, that's a 9. And then something quite clever here is that the sum of the remaining digits will be the sum of all digits from 1 to 8, which is 36. And this digit, and this sum, 36, is now the sum of all 4 digits in here. And 4 digits summing to 36, they will have to be all 9. So that's the very nice start in here. And then the next step is that the sum of those 2 digits is the sum of all 5 digits here. And if you're familiar with, let's say, Kira Sudoku or Kakuro, you will know that the minimum sum of 5 digits, namely 1 plus 2 plus 3 plus 4 plus 5, is 15. So those 5 digits have a minimum sum of 15. So the minimum sum of those is 15, which may only be achieved with 7 and 8. So it means that all 5 digits here are the digits from 1 to 5, and this is a 6. So is there anything similar? Well, almost here, except that we only have 4 digits. So those could have a sum as low as 10. So here we also have a sum that is at least 15. But is this the place to look? I'm not sure about this. So here we know that this digit is the sum of all those 3. So the minimum value is 6. It could also be 7 or 8. But one thing is certain, which is that those 5 digits here have a sum of at least 15. Plus that, this is at least 16. So this plus that is at least 16. And with a 6 here, that won't work. So the options are, let's say, 7 here and 9 there, or 8 here and 8 or 9 there. So the maximum sum here is 17, the minimum is 16, so we only have 1 degree of freedom. This is 1 or 2. All right, so now what do we have? What do we have? This, what we have, I really don't remember. That's the beauty of solving those long after the real event. I'm really wondering what I did find after this breaking. So something of interest here is that because of this, 9 is not there. And 9 won't lie on the arrow, so 9 is somewhere here, so 9 is in one of those two positions anyway. Which means that 9 must be somewhere here, but it's not here because of the 9 I've already found, and 9 can't lie on the arrow stem. I think it's called stem, I hope. So now by Sudoku, there must be a 9 somewhere here, but not on the arrow and not here, so that's a 9. And now there must be a 9 somewhere here, but not on the arrow, so that's a 9. And now this becomes 8, and this is 9. And that's interesting because this plus that must be at least 16. So this has to be 8. So that must be at least 18, so this is at most 1. And we know now that this is precisely 15. So all digits from 1 to 5, so we have a 6 and a 7 down there. So this is at least 2 and this at least 6, so this is at least 8, so it has to be 8, and it can only be done with 2 and 6, and that's a 7. So now those 3 digits plus those 2 have a minimum sum of 15. So this digit plus this one is at least 15, so this must be at least 7. So it has to be a 7, and there again, 6 can only go here. So that's a similar logic to what happened in this box. Now we know that just by the rules of Sudoku, 6 goes here, and 6 will go somewhere here, so either 6 plus 3 or 6 plus 3 in here. 2 is not here. 7 goes there by the rules of Sudoku again. So here we have 2 digits summing to 7. They could be 2 plus 5, they could be 3 plus 4. And the interesting part is that the same 2 digits will have to be here, but this is not saying much. So those 2 digits are the other digits summing to 7, and the same can be found here. That's not so interesting again. So 1 will be somewhere here. Those are from 3, 4, 5. This is also from 3, 4, 5. This is from 2, 3, 4. That's really not that interesting. What about this? This here can't be too low. It's a sum of 3 digits, so it will have to be from 6, 7, 8. Oh, actually, this 8 tells us, no, not quite. We could have 8 here with a 1. That's correct. Now, what I must be wondering is where 8 goes in this central box. Because of this and that, we know that 7 and 8 are somewhere here. But now 8 will be accompanied with a 1 if it is on this arrow, but 1 is here. So 8 has to go there, and this contains the 7 and the 2, and 1 is here. So now we have 3, 6, and 4, 5 somewhere, but 6 could still be here. 2 is down there, and 1 is down there as well. And that's interesting. So 1 and 2 go here, because what is the third digit? If this is 7, then the third digit is 4. If this is 8, then the third digit is 5. So we have a 4 or a 5 here. So we can't have both 4 and 5 here. So this 9 is done with 3 and 6. This is 4 or 5. This is 4 and 5 actually. And now we know that 3 is somewhere here. with a 4 or a 5. And the missing 4 or 5 must be here with a 2 or 3. All right. So seeing that now, what about 8 in this box? 8 can't be here. It can't be on the arrows, so 8 will have to go there. And by Sudoku, we get 8 somewhere here, but it could still be 8 and 1 here. So let's not jump to wrong deductions. 8 must be somewhere here as well. We don't have 1, so the minimum here is 2 plus 3, so the minimum here is 5. It can only be 5 or 7. What could be the digit here? Could it be as low as 3? 3 with 2 and 1, with 3 and 5 here. 1, 4, 6. That would seem to work. So where else am I supposed to look? So this, what are the options? Or is it the right place to look? Should I focus on this instead? I know. I should have seen this earlier. I know there must be a 1 here. Any one of those totals needs a 1 on this arrow. So I can't have a 1 here, so I can't have an 8 here. So this is really 8. And this is now 7 and now 8. So this is actually a 3-5 pair. And this is a 1-2-4 triple. So that's a 4, that's a 5, that's a 4, that's a 4, and that's a 3. 3, I said. So that's 5, that's 2. Oh, this is weird. Oh, PenPad checks if I'm doing something wrong by default. I didn't know that. It checks for conflicts. 3, 4, and here this is 1 and 5. So that's some measure of progress. So what is here? So, oh, there are 2 ways of making 8 as the sum of 3 digits. One of them is 1, 2, 5. The other is 1, 3, 4. But 1, 2, 5 is forbidden because of this. So this is 1, 3, 4. That's 2 or 5. And the second 2 or 5 is here with 3 or 6. Which is interesting because we have a second 3 or 6 here. We have a remote 3-6 pair here. So this is not 3 anymore, this is not 6. It could still be 4. Oh, let's focus on this. This 9 now can only be done with 2 and 7. And we have 5 and 6 on top. So this now can't be 5, 6, 8, 9. It can't be a 3. It could still be a 4 or a 7. That's not 2. So 4 would work with 1 and 3. It definitely would. 7. It won't be 2 plus 5. It won't be, it would work with 1 and 6. So 1 and 3 or 1 and 6. So there's definitely a 1 here. And down there we get a 1 in here. And I'm just saying that in this column, 2 has to be here. No, sorry about that, I'm wrong. No, actually, I should have seen there's a 2, 5, 7 triple here. Or another way of saying this is that 4 can only go in this cell. That's a 3, that's a 4, so that's the one, that's 3. Now that's 2, that's 5, that's 1. Here that's a 5. What did I say? That's a 2 with a 6, 3 and 6, 7 and 2. And down there 6 and 7. So that's 7, that's 6. So this is 5 with 2 and 3. So that's 2, that's 3. And that's a 4, 3 and 4. And there that's 5 and 7. So we're getting there. Here I need a 1 and a 4. Now 7 won't be here because no higher digit is available. So 7 on the column is here. That's 2. Now I get a 1-4 pair in the column, so that's a 3. I get a 1-4 pair in this column, so that's a 2. This must now be the highest remaining digit, so that's the 6. 4 plus 2 is not possible, so this is 1 plus 5. 4 here, 1 and 4. That becomes a 3. 6 and 5, which I could have found earlier, I'm afraid. And this 5 now disambiguates all of that. That's a 2, that's an 8, that's a 3, and that's a 7. So that was a difficult puzzle. That was definitely a difficult puzzle. And I think it caused me more difficulty than the quadruples puzzle. But I still think the rating of 120 points was fair. Most of the ratings were really fair in my opinion. I would just have rated quadruples a little less and entropy quite some more. Well, anyway, that was a remarkably constructed puzzle by Christoph. And I'm saying that for every one of the puzzles in this round anyway. Thanks for watching this video and see you soon. Auf SudoKanard!